Okay, nomenclature of molecular compounds. You will recognize these compounds because the elements present are nonmetals only. So, quick refresher, we find the staircase towards the right side of the periodic table. All the elements to the left are metals except for hydrogen, and the nonmetals are found to the right. So we're looking then at compounds, so particles that will have more than one type of element, and both of those elements will be nonmetals. Forget about the cross-down method, that's for ionic compounds only. We're going to use the prefix method for molecular compounds. That means you need to memorize this list. Mono is 1, di is 2, tri, you might think of a tricycle, 3 wheels, tetra, 4, penta, think pentagon, 5, hexa, hexagon, 6, hepta, so think of the French for 7, sept, and S-E-P-T, and so we have 7. Octa, I think octopus, 8 legs. Nona, I think of the older Italian grandmothers, so think 90 here, so 9. And deca, think decade. So the key is that the prefix will represent the number of atoms of an element that are in the compound. So really we'll be looking at the subscript. Take note that for mono, you only use it for the second nonmetal. So the common format then will be 2 words, so you'll notice blue here and blue here. The first word will be composed of a prefix, except for mono, we won't use that, with a nonmetal, no change to the ending. And the second word will be a prefix with a nonmetal root and IDE. Okay, so I'm asking you in number 1 to write the formula. So you'll notice this same format, carbon, and then tetrachloride. So we interpret the prefix as the number of atoms of that element that are in the compound, in other words, the subscript. So the fact that it just says carbon means that it's not dicarbon or tricarbon, it's monocarbon, except they didn't write the mono for the first word, which is correct. So C1, and tetrachloride. So for chlorine, there are 4 chlorines. Now, as with the ionic compounds, we omit ones in the final version of the formula, and so the complete or the final answer here is CCl4. Okay, moving on to the second example, dinitrogen tetroxide. Now you'll notice that I dropped the A. Typically when you have an A and O vowel together, you drop the A. That will come with practice. As you learn how to say them, that will help you learn how to spell them. So dinitrogen tetroxide. So again, we let that prefix of di tell us that there are 2 nitrogens in the compound. N2, and then tetra, even though the A is gone, tells us that there are 4 oxygens in the compound. Notice I'm going to the subscript. There are no ions forming here. Nonmetals are sharing electrons. We do not have ions at all. There's no cross-down method. The prefix tells us the subscript. The prefix tells us the subscript. So you'll notice right here that the 2 and the 4 are directly positioned as subscripts. Okay, try number 3 on your own. Then check back with the video. Okay, so hopefully you came up with CO. Again, we will not see mono for the first element, so if there's no prefix, you know it's a 1, and monoxide, so we had monooxide and dropped an O, so monoxide, and that means a 1, and so I've omitted the 1s. Okay, for examples 4, 5, and 6, I'm asking you to name each compound. So follow the format that we've discussed. And if you don't see a subscript, then you know that it's a 1, but remember not to use mono for the first element. So instead of monocarbon, I'm just writing carbon, and then the 2 right here has me thinking di. So carbon dioxide. Don't forget about that IDE ending. Okay, number 5. Try 5 and 6 on your own and check back. Okay, so just a tricky spot here. Often this mono is forgotten, so heads up on that. Dinitrogen from the 2, monoxide. Okay, and our last one here, again we ignore the 1 and finish with sulfur hexafluoride. Watch your spelling on the UO of fluoride there. Okay, there are a few common molecular compounds which you need to recognize by their common names and be able to write those formulas. So I suggest you memorize these. Now, I realize the ammonium ion is present on your polyatomic ion list. The ammonium ion has the formula NH4 positive 1, so not to be confused with NH3, which is a molecular compound by the name of ammonia. CH4 is our smallest hydrocarbon. It is the gas that makes up natural gas in your furnace and the gas jets in our classroom, and CH4 is known as methane. O3 is ozone, which you may have discussed or will in the climate change unit. We all know H2O as water and H2O2 as hydrogen peroxide. Okay, and the last part of this video addresses diatomic elements. Now, just to be clear, elements are not compounds. There's only one type of atom present. However, when these elements exist in nature, it's not a single atom together, it's two of them bonded together by a covalent bond. And so hydrogen exists as a gas, and it's two hydrogen atoms bonded together. So di meaning two, atomic meaning atoms. So these are elements that exist as two atoms together. So hydrogen gas is one of them, and then the two gases that make up the air that we breathe, so nitrogen gas and oxygen gas, as well as all of the halogens, so group 17, so F, Cl, Br, and I. Now, F2 and Cl2 are both gases. Once you get to Br2, bromine is a liquid at room temperature, and I2 is a purple solid. So the first group here are all gases, and then bromine's a liquid and iodine's a solid. When we write the formula of these diatomic elements, we write them exactly as I have here, H2, N2, O2, etc. And when we write their name, we just name them with the name of the element. So H2 is hydrogen, or hydrogen gas. N2, nitrogen, or nitrogen gas. O2, oxygen gas. Jump down to Br2, bromine, or bromine liquid. You do not say dibromine, so there's no prefix incorporated here. Literally, the name of the element is the name of these diatomic elements. Now, I just want to be very clear that when hydrogen is involved in other compounds, it doesn't always have a 2 with it. So we're writing the formulas of these diatomic elements as they exist when they are not bonded with any other element. So as you can see back up here in our common molecular compounds, that hydrogen in water, there happens to be 2 hydrogens in water, but in methane there's 4 hydrogens, and ammonia there's 3 hydrogens. And so these are compounds, 2 different types of elements, whereas down here we just have an element, just hydrogen. It's the only type of atom present. Yes, there are 2 of them, and that's what makes it a diatomic element. And so yes, you need to memorize these 7. You can learn them by the position on the periodic table, or some people like to remember them by the order of the word Hofbrinkel. So if you check out the spelling of Hofbrinkel, you'll realize that those letters cover off the same 7 elements that I've indicated in the group.